We're going to start the section on intermolecular forces. One of the factors that affects intermolecular forces is molecular polarity. Molecular polarity is dependent upon two things, one of which is bond polarity, which this video is on. Now, bond polarity deals with covalent bonding, and in covalent bonding, electrons are shared. However, electrons do not have to be shared equally. If the electrons are shared equally, we say the bond is nonpolar. If the electrons are shared unequally, we say the bond is polar. Electronegativity comes into play here. So with electronegativity, the more electronegative an atom is, the more time the electrons spend around that atom. This means that the more electronegative atom has a slight negative charge, not a full negative charge, but a slight negative charge. And this is the symbol for a slight negative charge. Conversely, the less electronegative atom will end up having a slightly positive charge because the electrons aren't spending as much time there. And this is a symbol for a slight positive charge. Electronegativity is a periodic function. Fluorine is the most electronegative element. Francium is the least electronegative element. So we can say that as you drop down a group, electronegativity will decrease. And as you go across a period, the electronegativity will increase. So, quick question, which is more electronegative, carbon or lithium? And the answer is carbon. Why? Because electronegativity increases as you go across a period, and so therefore carbon should be more electronegative than lithium. Which is more electronegative, nitrogen or arsenic? And the answer is nitrogen. Why? Because as you drop down a group, electronegativity decreases. If an element is bonded to itself, then you have a nonpolar bond. An example would be chlorine, which is a diatomic element. Since the Cl and the Cl have the same electronegativity, it is by definition nonpolar. However, if an element is covalently bonded to a different type of atom, it is polar. An example is oxygen bonded to hydrogen. And let's take a closer look at this. So we have oxygen bonded to hydrogen, and oxygen is more electronegative than hydrogen. So we will mark it red. We can therefore say that the oxygen has a slightly negative charge, and to make sure that things still have an overall charge of 0, the hydrogen is slightly positive. But there's another way to demonstrate this, and this is using an arrow. And that looks like this. The arrow goes from the slightly positive towards the slightly negative element, and to show which side is the positive side, we put the crossbar in there, which makes that end look somewhat positive. That line demonstrates what is called a dipole or a dipole moment, and it has a special significance. The dipole or dipole moment is a vector. A vector is a measurement that has both magnitude and direction. You can take various vectors and add them up to get a new value. A dipole is a vector, and the direction is from the slightly positive atom towards the slightly negative atom. And as we'll see in the next video, molecular polarity is dependent upon adding vectors. So to review, in a covalent bond, electrons could be shared equally, which would make for a nonpolar bond, or they might be shared unequally, giving a polar bond. In a polar bond, the electrons will spend more time near the more electronegative atom, so the more electronegative atom will have a slightly negative charge, where the less electronegative atom will have a slightly positive charge. The dipole moment is a vector. The direction of the vector goes from slightly positive to slightly negative. Vectors can be added together to make a new vector, and we're going to need dipole vector addition to explain molecular polarity. And that is bond polarity in a nutshell. In the next video, we'll tackle molecular polarity.